Welcome to the lesson on properties of a parallelogram. At the end of this lesson, you will be able to identify the different types of parallelograms and illustrate the relationships between them. You will be able to state and prove different properties of a parallelogram. You will also be able to prove that a diagonal divides a parallelogram into two congruent triangles. Let's first quickly recapitulate about parallelograms and their types. A parallelogram is a quadrilateral in which opposite sides are equal and parallel. Rectangles, rhombuses and squares are all different types of parallelograms. A rectangle is a parallelogram in which any one angle is of measure 90 degrees. A rhombus is a parallelogram in which all sides are equal. A square is a rectangle with all sides equal. Now, let's learn about the properties of a parallelogram with the help of an activity. First property we are going to prove is that a diagonal of a parallelogram divides it into two congruent triangles. Consider this parallelogram. Let's join any of its two opposite vertices. It divides the parallelogram into two triangles. The two triangles coincide, means the corresponding sides of both the triangles are equal. This implies a diagonal of a parallelogram divides it into two congruent triangles. Since the triangles are congruent, their corresponding sides and angles are equal. Thus, we conclude that in a parallelogram, opposite sides are equal and opposite angles are equal. Let's now join its other two vertices. It divides the parallelogram into four triangles. Consider these two. On placing one over the other, you will notice that they also coincide. This implies that the corresponding sides are equal. Thus, we can say that the diagonals bisect each other. Now, let's check that the properties of a parallelogram also holds true for rectangles, rhombuses, and squares. Let's draw any one of their diagonals. You will notice that in each case, a diagonal divides it into two congruent triangles. Thus, all the properties of a parallelogram holds true for rectangles, rhombuses, and squares. Let us now try to prove some of the properties of a parallelogram. First theorem we are going to prove is a diagonal of a parallelogram divides it into two congruent triangles. Consider a parallelogram ABCD and let AC be its diagonal. In order to prove that the diagonal AC divides the parallelogram into two congruent triangles, we will prove that triangle ABC is congruent to triangle CDA. In triangle ABC and triangle CDA, angle BCA is equal to angle DAC. Since AD is parallel to BC, and AC is a transversal, they form a pair of alternate interior angles. Also, angle BAC is equal to angle DCA. Since they form a pair of alternate interior angles, full AB parallel to DC and AC being a transversal. Side AC is common to both the triangles. Thus, from equations 1, 2, and 3, two angles and the included side of triangle ABC are equal to the corresponding two angles and the included side of triangle CDA. This implies triangle ABC is congruent to triangle CDA by the ASA congruence rule. Thus, a diagonal of a parallelogram divides it into two congruent triangles. This completes the proof. Now, continuing with same parallelogram, which is divided into two congruent triangles. By CPCT, we can say that the corresponding sides of the two congruent triangles are equal. That is, side AB is equal to DC and side AD is equal to BC. Thus, we conclude in a parallelogram, opposite sides are equal. Also, corresponding angles are equal. That is, angle B is equal to angle D. Similarly, on drawing the other diagonal, we get angle A is equal to angle C. Thus, we conclude in a parallelogram, opposite angles are equal. Now, let's prove the second theorem. If each pair of opposite sides is equal in a quadrilateral, then it is a parallelogram. Let ABCD be the given quadrilateral in which AB is equal to CD and BC is equal to AD. To prove quadrilateral ABCD is a parallelogram, we will show that a pair of opposite sides is parallel. Draw diagonal AC. Let's begin with the proof. In triangle ABC and triangle CDA, side AB is equal to side CD, denoting it by equation 1. Side AC is common to both the triangles, denoting this by equation 2. Side BC is equal to side AD, denoting it by equation 3. Thus, the three sides of triangle ABC are equal to the corresponding three sides of triangle CDA. Therefore, by the SSS congruence rule, triangle ABC is congruent to triangle CDA. Now, since the corresponding parts of congruent triangles are equal, therefore, angle BAC is equal to angle DCA. And angle BCA is equal to angle DAC. On adding, we get angle A is equal to angle C. Also, angle B is equal to angle D by CPCT. That is, opposite angles of the quadrilateral ABCD are equal. We know that a quadrilateral is a parallelogram if the opposite angles are equal. Hence, the quadrilateral ABCD is a parallelogram. The third theorem we are going to prove is, if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. Let ABCD be the given quadrilateral in which diagonals AC and BD bisect each other. This implies BE is equal to DE and AE is equal to CE. We have to prove quadrilateral ABCD is a parallelogram. Let's begin with the proof. In triangle AEB and triangle CED, we are given side AE is equal to side CE, denoting this by equation 1. Angle AEB is equal to angle CED, since they form a pair of vertically opposite angles, denoting this by equation 2. Also, side BE is equal to side DE, denoting this by equation 3. From the above equations, two sides and the included angle of triangle AEB are equal to the corresponding two sides and the included angle of triangle CED. Thus, by the SAS congruence rule, triangle AEB is congruent to triangle CED. Now, since corresponding parts of congruent triangles are equal, therefore, angle ABE is equal to angle CDE, which are the alternate interior angles for lines AB and DC and transversal DB. Thus, AB is parallel to DC. Also by CPCT, AB is equal to DC. Thus, in the quadrilateral ABCD, we have a pair of opposite sides equal and parallel. Hence,